Hey guys, this is Fred from Pretty Fly Games, and today we're going to continue with our top-down car controller built in Unity. Today we're going to add support for lap counting and position tracking in our top-down car controller using checkpoints. So let's get to it and see how we can build this with Unity. I took the last course that we created, the one with the bridge, and added 3 cars to it. Now the first thing we're going to do is add some checkpoints so we can tell that the cars are actually passing through the course as we have intended to. So let's create an object and we'll call it checkpoints, and we'll just center it at 0, 0, 0, and then we will add a child object and we will call it just 1, and we'll add a sprite to it, just as we did with bridges, and we'll use our white 64 that we used before. Okay, and let's move it into position, and then we'll add a box collider 2D to it and make it a trigger. Alright, so now we're going to position this at the finish line, because this is going to be our sort of start and finish line. So just drag it out here and like that. And then I'm going to go ahead and add a bunch of more checkpoints. And you can add as many as you want. The more checkpoints you have, the more granularity you will have of which car is actually first. So when I think about it, let's just make this a little bit bigger so the car can actually drive a little bit off-road when passing through the checkpoints. Alright, we'll do that one and we'll call it just 2. And then I will speed this up so you don't have to watch me doing all the checkpoints. Alright, that looks pretty good. It doesn't have to be perfect. And then we will just disable our sprite renderers. So the only thing that is left is our triggers. And then we will create a new script and we'll call it checkpoint, and we'll open it in Visual Studio. Now in Visual Studio, let's delete all the methods, and the only thing we need is 2 variables, is finish line, which is a public variable, and the checkpoint number, which is an integer. So let's get back into Unity. Then in Unity, let's select our checkpoint game objects. We'll drag the checkpoint script into them. And then it's important that we assign the correct numbers and if it's a finish line or not. So this is our finish line. So that's going to be checked. And then we have our checkpoint number 2. So we'll just assign number 2 to it. And 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, perfect. So now we will add a new script. And we will call it car lap counter. Let's open it in Visual Studio. So first of all, let's get rid of the default functions. Then we will add 2 variables, one integer, past checkpoint number, and a float, time last past checkpoint. So these 2 will determine which car is in front. So the car that has passed through the most checkpoints in the least amount of time is the car that's going to be ahead of all the other cars. So how do we determine when a car has passed a checkpoint? Well, we will use the same code as we did for the bridge triggers. So we will react to on trigger, enter, with a collider 2D. Then we will need to check if it's a checkpoint tag. So we need to assign this later in Unity. And if it's a checkpoint tag, then we want to get the checkpoint script that we have attached to our collider. What we want to do then is make sure that the car is actually passing the checkpoints in the right order. So we want them to pass checkpoint 1, 2, 3, 4, and not checkpoint 1, 3, 2, because it means that they have not followed the course that we have laid out. So let's make a check of that. So we look at our checkpoint number, and it should be one larger than our current checkpoint the last one that we checked or passed. And then we will use the checkpoint and compare it with that value, because then they should be the same. And if they are, it means that we have passed our checkpoint, and then we can change our past check number to that. So we can, well, let's do it like this. We'll add it to the checkpoint. We'll assign it to the same as the checkpoint number. And we also want to store the time, as we said before. And let's also actually do another variable, and we will call it number of past checkpoints. Number of past checkpoints, because it's going to be easier to compare than this value. And we will increase this value by 1 when we have checked past a checkpoint. Okay, then we're going to do something new that we haven't done before. We're going to use an event. So an event tells other script that something has happened. And we're going to use the C# events and not the Unity events, because they are much easier to use. So let's add a public variable. It's going to be an action, and it's going to be our car lap counter, and the event that will be triggered is on past checkpoint. And we need to be using system, because these action events are a part of the system. And when we have passed our checkpoint, then we want to invoke this event. And what we do is we take our event and we use this question mark dot. That means that it's not null, and then we invoke it. So with this, we have the ability to tell other scripts that, okay, our car has passed the checkpoint. So let's get back into Unity, because we need to create another script. And before I forget it, let's select all the checkpoints. We'll add a new tag. Let's call it checkpoint, as we did in the script. And then we'll assign it to all the game objects. And then there is actually a little bit of a mistake. Our first checkpoint is not gonna be the finish line. So let's uncheck that, move it forward a bit. Let's move the second one, and let's rotate it and put it over there. Then, where's our 11? We'll add another one, call it 12. And we'll call it is finish line, and then it's going to be point number 12. So our checkpoints are going to be 1, 2, 3, 4, etc. And then the last one is going to be our finish line. We can actually move it so it aligns properly, like that. Okay, perfect. Oh, also one more thing. Let's open our cars, the prefab, and let's assign our car lap counter to it so we don't forget it. And then we can save, exit, and then we can create a new script, and we will call it position handler. Let's open that in Visual Studio. Okay, so let's get rid of our update method, and then we will add a list. Because this is going to be the script that tracks the positions of all the cars and everything around that. So we want to have a list with all the car lap counters, or car lap counter, and we'll call it car lap counters. And in the start method, the first thing we want to do is find all of our cars that has the car lap counter attached to it. So we'll use the find objects of type car lap counter and put them into an array. But then we want to store it in a list to make it more easy to manipulate it. So we'll take our car lap counter array, this, and we'll use a to list. And this requires link. So let's use system.link, and we convert it into a list. Now that we have that, we want to be able to react to our event that we had already added to our car lap counters. So we want to have an event called onPass checkpoint, And this one is going to get triggered when a car is passing a checkpoint. And we want to hook up the events from the car lap counters or the cars. So let's do that. We'll go through all of our car lap counters in our car counter list. And then we just add the event, subscribe to the event by using plus equal and then the name of the function. If we take this function, we can add a debug.log and saying that, an event has happened, a car with the name has passed a checkpoint. So let's save it and see if this works. So let's take our main camera and we will add the position handler to it. I like to use the main camera because I know that it's going to be in all the scenes. So that's where I usually put scripts that needs to be included in the scene, but not on specific cars or anything like that. Now the car lap counter, the list that we did is a public variable, and I did that just so it shows up in the inspector so we can see what happens. So if we press play now, it should populate the cars already. We can see that, we have the different cars here. And if we drive them and we look in our console, then when we are passing our first checkpoint, we're going to have events. So car red 1 passed the checkpoint. Car blue passed the checkpoint, etc. So we can see that our event system is working and the detecting part is also working. So if we cheat a little bit and we drive in reverse, we can see that, it's not actually detecting any checkpoints, which is great because we are cheating, we're driving in the wrong direction. If we continue to drive forward and enter the bridge, like that, we can see that a lot of events are getting fired all the time, which is perfect. Now there are a few more things that we need to add to the position handler so it can sort which car is in front. So let's start by going back into our car lap counter. So the first thing we're going to add is the support to count laps. After all, the script is called car lap counter. So let's start by adding a lap counter to it, and we'll call it laps completed. Then we need to know, how many laps are we supposed to complete before the race is over? So we'll add a constant integer laps to complete, which is 2. And then we're gonna check in our script here. When we have passed a checkpoint, we need to check basically if it is a finish line or not. So let's go and check if checkpoint is finish line. Then what we want to do is we want to have our laps completed, and we'll add 1 to that. And then we need to make sure that the past checkpoint number is going to be 0 because we need to restart again. And that's about it. Now we can calculate how many laps our car has completed. And we want to have sort of a way to detect that, when are we finished? So let's go and add another variable and we'll call it is race finished or is race completed. And we'll add it at the bottom. So if we have, when we are checking that we passed the finish line and we are increasing the laps completed counter, then we can also check have we actually completed our race or not. So if the lap counter is larger than laps to complete, then our race is truly finished. And what we want to do as well is that if our race is finished, then when we are entering on trigger here, then we don't want to do anything really. Because we don't need to check any checkpoints, we don't need to do anything specific after that. Then we're gonna add another variable. We want to be able to track the car's position, so we need a variable for that. So let's add car position. And this script alone will not be able to detect what position the car has, because that is handled by our position handler. So we need a function that can set this value. So let's add a set car position as a public variable or public function. Set car position takes an integer and just sets that. Then for our position handler to work, we actually need to retrieve some values from this script. So the first thing we want to be able to retrieve is the number of checkpoints passed. Number of past checkpoints. And then we also need to determine what the time was, or what the time is when we pass that checkpoint. So let's add that as a function to get the time at last checkpoint, and it returns time at last checkpoint. Perfect. So now we can go back into our position handler. So let's delete our debug line, because we no longer need it, because we know it works. So what we want to do is, now that we know that we have received an on-pass checkpoint, we want to sort the list. And we will do this by taking our car lap counters list, and we will use a link statement, order by descending. That means that the value that has the highest value will come first. And we'll take the first parameter, and this is can be any value, but we'll call it S. And then we say that, okay, S, get the number of checkpoints passed. So that's going to be a value 1, 2, 3, 4, 5, 6, 7, and it never stops. So it's going to be a higher and higher value. The more checkpoints you have passed, the better it is. And then we're going to sort by the time it has taken to complete the checkpoints. And the lowest time is better. So that's why we use then by, because then it's sorting ascending. That means the lower times will give you a better ranking. And then we need to make sure that this becomes a list again, and we assign it to our car lap counters. Perfect. So now we can determine what position a car actually has. And what we do is we take our list, and we know that this is the object that has passed through our checkpoint. So we know that this is the specific object that we want to update. And what we do is we look at the car lap counters, and we use a function called indexOf, which returns which position this object has in the list. And we add 1, because a list starts at 0, and we don't want to have a position of 0. We want the positions to be 1, 2, 3, 4, 5, 6, etc. And then we will take our car lap counter, and we will tell it that, hey, you know what, this is your new position. Okay, so let's save and take it for a spin in Unity. Okay, so let's start the script in Unity, and we can have a look at the main camera, and we can see that it has the cars in it, and it's in a random order because Unity has just started up, and it has found our car lap counters and put them in this list. So let's change the order a little bit. We'll put the blue car in front, and then we'll take our red car 1 and put it in the behind. And we can see that it still has not updated because it has not passed through a checkpoint. So let's drive a little bit ahead, and we'll see what happens. All right, so now it has changed order. The blue car is the first car because it has passed a checkpoint. And the second car is red 1, which is not correct. And the reason for this is it has still not passed a checkpoint. So we drive ahead a little bit more, and then we can check the order now. So now we have car blue is 1, first car. Car blue 2, red 2 is the second car. And the last car is red car 1. Perfect. So it is working. Let's see if we can nail another checkpoint. Yeah, made it. All right, so let's have a look at it now. Now it should have changed order. So we have car red 2 is the winning car right now. Car blue is the second car. And the third car is car red 1. Awesome. Okay, so we want to make this a little bit more interesting to visualize the positions that the car actually have. So let's open our car prefab, and under the car, let's create a new UI object, and we want to create a text, and we will call it position text. Now the canvas is something that we can use to draw UI objects, and the position text is a label, a text that we can use. So what we want to do is we want to change this rendering mode from screen space to world space. That means it will be in the same space as the camera. And then we can make it a lot smaller, 100 times 50. And we'll place it directly above the car. And the scale of canvases are massive. So let's just bring it down to 0.1, 0.1, and 0.1, something like that. And then we can move it ahead of the car a little bit. And then our position text, we need to center that as well. And we'll center the text properly, put it at width 100, make it a little bit bigger, show position, just a 1 for now. And then we'll change the color because gray is so boring. I'll just make it a bright blue. And yeah, then we will hide it because we don't want to show the position all the time. Then let's open our car counter in Visual Studio. Okay, so let's add the text as a public variable, and we need to be using Unity Engine .ui for it to work. So now we'll take in a public variable. It's a text, car position text. Then we want to sort of animate it or show it for a little bit of time, not all the time. So we will use a coroutine called show position CO. I like to use the CO so that I know that it's a coroutine. And it will take in a variable, delay until hide position. Then what it will do is it will take our car position text and set the car position to a string. So we change it into a string. And then we will take our car position text game object and we will set it active so that users can see it. And then we wait for a while, and that while is specified in the delay until hide position. So we wait until this time has passed, and the code will basically stop here. And then after this time has passed, the code will continue. So what we want to do once the time has passed, we want to hide it. All right, perfect. So when do we want to call this? Well, here's the tricky part. When we are doing all this processing, the last thing that we are doing is that we're activating or invoking our event on pass checkpoint. Our position handler will then sort the list. So not until this has happened, at this point we don't know what our position is really. So we need to wait until that is completed, and after that we can show our text of our position. So we can do it a little bit different. Let's say that, okay, if we have passed, or if we have completed our race, then we're going to show our position for a longer duration, 100 seconds. And if we have not completed our race, we're going to show it for a shorter duration, 1.5 seconds. Okay, so let's get back into Unity and try this. Oh yeah, I almost forgot. We need to change the canvas sorting layer because right now it's set to default. So if we're driving above a bridge or under a bridge, we won't see it. So let's just set it to particles, and then we can save and take it for a run. And the car's positions should now be updating properly as we are passing the checkpoints. 1, 2, 3, yeah, great. And then 1, 2, 3, awesome. And let's just get rid of some of the cars so we can see that it's working. 1, 2, 3, awesome. So now we have a clear winner here. The one. Let's see if we can have the blue take over. All right. Well, it's the red car. The reason why they are sort of glitching in and out, the numbers is, or the precision is because the coroutine is getting called all the time, and we have a lot of checkpoints. So it's getting called here, and it's getting called here. So it will just overwrite its own state. So let's fix that in Visual Studio by opening the car lap counter again. So to fix this problem, we're going to add two variables. One is a state, is hide routine running, and the other one hide UI delay time. So if we scroll down into our coroutine, so the first thing we want to do is we want to change this hide delay time. So we take in the value that we're getting from the function and we'll add it to the delay time. So if there's only 0.5 seconds left and we get another 1.5 seconds from a new function call, then we'll add them together. And then we'll change to wait 4 seconds for this hide UI delay time. Then we need to determine if the function is running or not. So we'll add it here if this function is running. Or if it's not running, then we will change it to yes, it is running now. And then when we have completed it, or completed the wait time and we have hidden it again, then we're going to say that no, it's no longer running. So if we save this and run, our glitch should be gone now. So if we run the game now, we can see that the car positions are being updated, and they are getting hidden when the cars have not passed another checkpoint for a while. And if we complete the race, they're going to remain for a little bit longer. So this concludes today's session when it comes to checkpoints and those things. So if you like this video and want to see more like it, please hit the subscribe button, and also give this video a thumbs up if you like it. Now, we're gonna backtrack a little bit and cover a bug that I found on the bridge handling. So let's stop here and I will show you the problem. So the problem with the bridges is if we take our car controller or the cars and we drive them, and let's park them over there, and let's take the red cars, we'll disable the car controllers, and then we will take our blue car and we will drive under the bridge. The problem now is that they are colliding, and they shouldn't be colliding. So how do we solve this? Well, we need to use Unity's layer sorting, or actually collision sorting, a little bit better. So if we take our car red and we look at the layers, then we need to add two new layers. One is object on overpass and the other one is object on underpass. If we go into our physics settings for this project, physics 2D, we can disable the collision between these two layers. So object on underpass should not collide with objects on overpass. So let's disable that. And then we need to go into our car layer handler and change the code. So in Visual Studio, let's scroll down, and the first thing we want to do is take the car collider, take its game object, change and the layer, and we change it, and the default value should be that it's driving on the underpass. Then as we are changing our sorting layers, we want to also change the behavior. So when we have this is driving on overpass false, we will change the layer of the car collider again, and the opposite when we are on the overpass. So if we are driving on the underpass, then we should have the layer object on undermask. If we are driving on the overpass, we should use the layer object on overpass. Alright, so let's save that and try it. So if we run that again in Unity with the same setup, now we can see that our car, blue car, is not colliding when it's driving below the bridge, and as it's above the bridge, it is colliding again with the cars. So that was a fairly simple fix to this problem. Alright, that's it for today. Here's an example from our game, Total Arcade Racing, which uses this component. You can find the game on Steam or Nintendo Switch. Please take it for a spin if you want to.